Hello everyone, let's talk about the concept of refraction of light. Uh, what is the refraction of light? This refers to the bending of light as it passes through different medium. So if the light passes through different medium, maybe air and water, it tends to refract. So that's what we call the refraction of light. So this bending takes place because the speed of light tends to change when it's traveling from one media to another. For reflection to occur, the two media must have different densities. As I said, example, air and the water. Now let's see the angle of incidence and the angle of refraction. What is the angle of incidence? The angle of incidence, this is the angle between the incident ray and the normal ray at the point of incidence. At the point of incidence, this means at the point of where the light passes. So let's see the angle of refraction. The angle of refraction, this is the angle between the refracted ray and the normal at the point of incidence. So angle of refraction is related to the refracted ray and the normal ray at the point of incidence. Let's see the laws of refraction. The first law of refraction, this states that the incident ray, the normal ray and the refracted ray at the point of incidence are located in the same plane. So this is the first law, that the incident ray, the normal ray, and the refracted ray at the point of incidence all are located in the same plane. So you can see them in the same plane, all these three of them. While the second law of refraction says that when a light passes through one media into another media, the angle of incidence and the corresponding angle of refraction are such that the sign of the angle of incidence to the sign of angle of refraction is the constant value called the refractive index. So that's how the second law of refraction can be stated as. Let's see what is the refraction index of a material. When we're talking about the refractive index, we are talking about the ratio of the sign of the angle of the incidence to the sign of the angle of the refraction. Also, we are talking about the ratio of of the velocity of the light in the first medium to the velocity of the light in the other medium. While also refractive index also is the constant number which expresses like how many times or to what extent a light ray bends when it passes through different media. The absolute refractive index is what we call the refractive index between the vacuum or air and the other material. So you can definitely define the absolute refractive index by simply saying is the refractive index between the vacuum or air and the other material. Let's see what is the real and the apparent depth. When we're talking about the real depth here, we mean that the actual height measured without taking account of any refraction of light in the process of refraction, while the apparent depth is this is the virtual height measured when viewed by an observer after the refraction. The real and the apparent depth can be seen when, example, viewing a spoon immersed in water contained in the glass. When the spoon is viewed from the top of the glass, it will be seen as bent. So you can simply say how the real and the apparent depth can be observed. Now the bottom of the river also can be seen to be lifted upwards through the real level of the bottom. Real bottom is deep below. So you can simply show uh, the application of the refraction. So the lifted bottom is known as the apparent depth. Let's see the concept of the critical angle and the total internal reflection of light. Critical angle here will mean that is the angle of incidence from which the angle of reflection is equal to the 90 degrees. It is obtained when the light rays moves from a dense medium to a less dense medium. So from theoretical, you can say that when n is equal to sine I over sine r, where I is a critical angle that is 90 degrees, you can simply say that n equals to sine c over sine 90, where sine is also n is equal to sine c over 1. So specifically, you can just say N is equal to sine C. That's the critical angle. Well, when you're talking about the total internal refraction, this occurs when a light ray from a less dense medium is reflected into the denser medium at the boundary separating the two medium. The conditions for this is that internal reflection should to occur. The first one is that the light must be traveling from more dense to a less dense medium. Also, the light must be incident at the boundary at the angle greater than greater than this the critical angle. I hope it's clear. We've talked about the few terms and these common terms in the refraction. So thank you.